So you're finding the area in here between the two.
Okay.
So it's the x value. It's from 0 to 3. No, it's the x values you care about. I know the y's are the same, but it's only the x values. And then it's top minus bottom. Top minus bottom. So you gotta be really sure that you know what the top minus the bottom is, because if you don't do that, you get negative of the answer. And there is kind of a
Mhm.
workaround here, but you really want to be good with that. So it's negative x squared plus 4x minus x squared minus 2x. Now, since you're using your calculator, you don't have to do any simplification. Meaning
Okay.
like normally you do this by hand, and or, you'd have to combine like terms and stuff. So why don't you put this in your calculator and see what you come up with, please? That math 9 thing we've been doing. You're gonna do a bunch of that on the test anyway.
Yeah.
Did I mess this up?
Okay. I got 3.
I got the wrong sign there. That's why. So I got 9.
Okay.
Did
Maybe.
you put parentheses around all this? Maybe parentheses around all
Yeah.
this.
I forgot to put an X next to the 4. That's what I did wrong. Yeah.
All right, that will for sure do it. Now, if you did the wrong order, like let's say you just didn't do it right, you're like, you did this one on the left minus this one on the right, you would get -9, and you can
Okay.
never get a negative answer. So be on the lookout for that. Like, so there is kind of a workaround, which is to use absolute value, but I don't see a need to kind of bring that up at this point for you.
Okay.
Oh boy. All right. So number 31 here. Um, Newton's method. It's a great method. It really is really useful in real life. A lot of algorithms are use Newton's method, but for a student here, you're like really not excited about it. So you have to know this formula.
Okay.
X1 equals X0 minus f of X0 over f prime of X0. So the next one equals the previous one minus the ratio of the function evaluated at that point over the derivative at that point. Okay, so this right here is your f of x. Your f of
Okay.
x is x cubed minus 2x minus 5, and your f prime of x, it's 3x squared minus 2. So x1 is equal to 0 minus f of 0 over f prime of 0. A lot of zeros, but um, f of 0 is not 0. F of 0 is putting 0 in for x. It ends up being
Mm-hmm.
just minus 5.
Mm-hmm.
F prime of 0 is minus 2. So x1 ends up being 0 minus 5 over minus 2, which ends up being negative 5 over 2, or negative 2.5 if you want. But that's not the answer. We want x2. Right. So to get x2, it's this formula up here that I'm boxing in. It's this formula, but instead of a 1, it's 2. Instead of a 0, it's 1. So x2 equals x1 minus f of x1 over f prime of x1. Okay, and we know that it is minus 2.5. F of x1 we do have to calculate. So you've got to go back here and you got to find f of minus 2.5 and f prime of minus 2.5. So I'm gonna use the calculator for both of those because
Mm-hmm.
why not? Why not? You don't push your car, you get in it, you drive it. right, so for the first one, I get minus 15.625. Or I would double check these, if you don't mind. It's 16.75. Okay. All right, so where does that leave us?
Mm-hmm.
This right here over 16.75. And then rounded, I think it's at 4 decimal places. Like that.
Yeah, it says it was correct.
Okay. So next one here is 41. I don't remember us doing anything like this in our sessions. Doesn't mean you haven't seen it.
Yeah.
41 here. So it's odd. It's like, wait, derivative of y, but y is an integral. So
Mm-hmm.
there's a recipe here. So what it is you take this thing right here, this top bound, and you put it in wherever you have a variable. So it
Okay.
becomes the square root of 3 plus 4w squared. And then this last part is almost always forgotten, but you multiply by the derivative of w, which happens to be 1, so it doesn't contribute. But if
Okay.
it were more complicated, it would. So your answer here is 3 plus 4w squared square root.
Okay. Also said that was correct.
Right, excellent. Number 4. Determine all critical points for the function. This means 1, determine f prime of x. 2, set the derivative equal to 0. All
Okay.
right. So could you attempt to give me the derivative of this, please? It is power rule.
Yeah, it would be 24x, negative 24x, yeah, plus 6x squared.
Right. So very good. So you'd set this equal to 0, and then you factor. So you can factor out a minus 6x. That becomes 4x minus x, like that. Oh, sorry,
Mm-hmm.
4x, 4 minus x. That's really bad. 4 minus x. And then you set both of these equal to 0. So you set minus 6x equal to 0, 4 minus x equal to 0, x equals 0, x equals.
4.
Those are your critical points. You could do it without calculus by looking at the graph and
Uh-huh.
seeing where like the horizontal tangents are, or like there are these points here, but you may not see them. Especially if it's a horizontal tangent.
Mm-hmm.
So,
Yeah, I said it was right.
perfect. Let's use L'Hopital's rule to find the limit. You start by putting the number into the equation. So it ends up being 6 times 5 minus 30. 3 times 5 squared minus 75. And in both cases, you get 0 over 0, which is called indeterminate form. So what that means is you can't evaluate the limit, as is this L'Hopital guy, probably famous French mathematician. he figured out that if you take the derivative of the top and the derivative of the bottom over and over and over again, you eventually get the answer. So the derivative of the top is 6. The derivative of the bottom is 6x, like this. And what you can do is you can simplify, see how the 6's cancel, but be careful there. I mean, when the 6's cancel, there's still a 1 in the numerator.
Mm-hmm.
And you're still putting that number in for x, so it ends up being 1/5. We talked about a way to do this on the calculator, which is to pick a number really, really close to 5, like
Uh-huh.
5.00001 or 4.99999. And you would get really close to 0.2, and you would just look at the answers and see which one matches that when you are um when you're looking there at the multiple choice. So anyway, the answer is 1/5. Hopefully that's correct. That's 25, by the way. Sorry for not putting that up there earlier.
Okay.
25. Yeah, these are somewhat different than your homework. I mean, they're all in the same class, but they're just not exactly same. Okay, number 11 here. Number 11. Find the function with the derivative whose graph passes through the point. And what they're asking you to just find the antiderivative of this, basically the integral e to the 3x dx. This is a u substitution problem.
Okay.
You would make u 3x, du is 3 times dx, dx is du divided by 3. And so you substitute in integral e to the u du divided by 3. So it ends up being 1/3 integral e to the u du. And so you know off to the side here, the integral e to the x dx is itself. Some of the reference sheets, which I know you don't get, they say if it's e to the kx dx, it ends up being e to the kx divided by k.
Mm-hmm.
You draw plus c. So, and you'll see that here. It's like, okay, well, the antiderivative is e to the u, but u was really 3x. The k in this case is 3, so it's 1/3 e to the 3x plus c. But then we have that initial condition. We have the fact that it goes through the point 0, 4/3. So
Mm-hmm.
let's do f of x equals here. So we're saying that 4/3 equals 1/3 e to the 3 times 0 plus c. And so e to the 0 is 1. 4/3 equals 1/3 plus c. C ends up equaling 1. That goes back into this line here. 1/3 e to the 3x plus 1, like that. Um, all right, so the next one here looks like it's a calculator problem. This is 37. So average value, find the average value of the function. The formula for average value is integral from a to b, f of x or f of t dx, 1 over b minus a. And it does have an important geometric meaning, but you don't need to know that. You just need to know that average value is this. So for you, it's the integral 1 over 12 minus 0 from 0 to 12, t minus 6 squared dt. And you should be able to go right to your calculator for this one. Do calculate it. Why don't you give that a try, please? I'll do the same on my side. Let's see if we get the same thing.
I got 12.
Two. Good. Right. Okay, so the most general antiderivative, this is number 32. There's 32 here. So these are all, there's a couple, the rules are, we've covered one of them. The integral of x to the n is x to the n plus 1 over n plus 1. If it's k times x, the integral of k times x, it's k x squared over 2. If it's the integral of just a constant, it becomes kx. So these three apply. They're actually all the same, but like they're usually spelled out, individually for this. So like the integral of the first one, okay, is you're going to take and add 1. 3 plus 1 is 4 divided by 4. For the second one, it's really 3x to the 1, so it's minus 3x squared over 2. The last one was just a constant, you add an x there.
Yeah.
And then plus c. It says to check by differentiation. I mean, that's how you're going to work through those multiple choice answers, is maybe go to the answers, take the derivatives, and see which ones work out.
Okay.
So we got this is 39. Evaluate the integral. So if this were on the test, you'll find your calculator does not have secant there. So you have to remember that secant is really 1 over cosine squared x.
Mm-hmm.
There might be a bit of an issue how to actually enter that, but you should be able, like, it's equivalent to cosine x squared, like that. And so if it were me and I, was kind of on the fringe about really wanting to get this stuff down, do this, and you're going to get not an exact answer, but whatever you get, you would compare to the exact answers. Now we can do this by hand, but that is kind of the suggestion here. So the integral of secant squared x dx is a known one. It's tangent x. So this is 7 tangent x evaluated from 0 to pi over 3. And we talked at length that it's top minus bottom. So it's 7 tangent pi over 3 minus 7 tangent 0. So tangent of 0, you'll be okay with. This one, you probably will not get an answer you like, though. That comes from the unit circle, that comes from your trig class, and there's no shortcut for that. So we can quickly look at the unit circle here to review. This is 0, tangent 0, 0. Your calculator would tell you that as well. It would give you that answer. So tangent pi over 3, so it's 7 sine pi over 3, because tangent is sine over cosine pi over 3. Some students learn it as y over x. So here at pi over 3, there's the y value, there's the x value. So it's 7 times the square root of 3 over 2 over 1/2. like that.
Okay.
And, you know, you're,
Thank you.
you okay?
Yeah.
All right. So this does simplify, the twos cancel, and ends up just being 7 square root 3, like that. So next one, sorry, I got thinking you were gonna send the next one over. You are not. This is 28. All right, so it says find the smallest perimeter and the dimensions for a rectangle with an area of 49 inches squared. Um, I want to do this. There's like a shortcut here, which is how do I do this? So the problem is, okay, the problem is if you just like do a standard rectangle, you're like, all right, you're like, okay, this is X, this is Y. We know that X times Y equals 49. And we know that the perimeter is 2X plus 2Y. You would have to solve this equation, Y equals 49 over X. And that goes in here to this equation. So it's 2X plus 2 times 49 over X, which is 2X plus 98 over X. And then you would solve this by taking the derivative and setting it equal to 0. You could also graph this.
Mm-hmm.
Graphing's a good prospect. I don't remember what you did in your last exam.
Mm-hmm.
Um, do you know if you spent time graphing these, or
Yeah, I spent a lot of time graphing a bunch of stuff.
that's a good strategy. So if you were to graph this, that's the pre-calculus way to do it. If you were to graph this rather than take the derivative, you'd get something like this. You'd say, okay, the minimum is right there at 7 when X equals 7. You'd go back and find that Y also equals 7 because X times Y equals 49. And you'd stare at these numbers and you might eventually say to yourself, well, that's a square. And so the shortcut to these problems is that they're often squares. Like if it's a rectangle, it's a square. Um, that's not the answer, but that's something to just sort of think about here. Like you shouldn't be
Okay.
surprised when you get the same ones. So the perimeter of this is 4 times 7, which is 28. You mind if I took just a 2-minute break here, 2 or 3
Yeah,
minute
go ahead.
break? Keep going. All right, be right back. All right, thank you for your patience. I'm pretty sure we're gonna get through all of these. So
Okay.
looking at 13 next. All right, consider the following acceleration. We did do something like this. If you integrate acceleration, you get velocity. And the acceleration function is given here. It's just a number, which is okay. So the velocity is the integral 9.8 dt. T because it's a function of time, says that there, it's a function of time. This is 9.8 t plus c. When they give you an initial condition for velocity, they say at time 0, velocity is minus 5. What that means is v is minus 5 and t is 0. So you can solve for c. C is minus 5. So that goes back here. Your
Okay.
velocity is 9.8 t minus 5. You're feeling great, but you're only halfway there.
Okay.
So the next thing here is to find position. Position is the integral of velocity. So you have to do the integral of 9.8 t minus 5 dt. I'm switching colors here just so you can see the transition from velocity to position.
Yeah.
And just like before, it's power rule. It ends up being 4.9 t squared minus 5t plus c. And then we have that initial condition s of 0 equals 0. Often, but not always, that means that the constant is 0. Just be careful with that. So in this case, the constant is 0.
Okay.
All right. So your s of t is just this. So the main thing is you integrate twice, you use both initial conditions, and then you get you get your position function.
Mm-hmm.
All right. Let's look at next one here. Number 8. 8. All right, so find the values or values of c such that f of b minus f of a over b minus a equals f prime of c. So they're giving you a, they're giving you b, they're giving you a function. So you've got to find, or what you're finding first is f of 12 minus f of 7 over 12 minus 7. So f of 12 is putting 12 in for x. Square root of 12 minus 7, well, that doesn't work out, is the square root of 5. F of 7 is square root of 7 minus 7, which is 0. So this ends up being square root of 5 minus 0 over 5, or square root of 5 over 5. So that's everything we just did is for this part. Now we're going to do the f primacy. So we got to take the derivative of f of x. It ends up being 1 over 2 square root x minus 7. You can think, if you need to, you rewrite it as x minus 7 to the 1/2 power. That's where the 2 comes from on the bottom, the 1/2. Negative 1/2 square root is the square root on the bottom. And so you set that equal to this right here, and then you solve for x. Okay, which is a little bit of work here, but that is the core of it. So let's do it. We're gonna multiply diagonally. I guess that's probably the most common way students would do this. So it's 5 equals 2 square root x minus 7 times the square root of 5. I'd probably square both sides instead of trying to mess around with this. So if I square this side, square this side, on the right, you're squaring each of these. So it's 4x minus 7, 5 like that. And then 4 times 5 is 20. So you would have 20 times x minus 7. Divide by 20, ends up being 5/4. X minus 7. This doesn't work out great, but it doesn't say fractions. But we'll just go with it. So you would obviously want to, like, if this were your problem, you'd want to maybe like use the answers at one point and see if it worked out.
Mhm.
I still don't like this square root of 5/5. Yeah. All right. So 7 is really 28/4, which is 33/4 equals x.
Okay.
So give that, please check that. This is number 8. Make sure that that actually does work.
It says it does work, yeah.
Okay. It didn't say, you write it as a fraction, because that's usually an indicator that you're on the right track for that.
Yeah.
Okay. It says, suppose that the second derivative function is given. Right now, they're giving you the second derivative. Like, you don't have to calculate the second derivative. They're giving you the second derivative. It's really important to make sure you see that. Now it wants to know, well, where does it have an inflection point? So it's an inflection point when the second derivative equals 0. So you're literally setting x plus 4, x minus 5 equal to 0. You're setting each of those equal to 0. And you're solving for x. And you want problems like this because you are done. You're totally done. The answer is minus 4 comma 5. You're just setting the second derivative equal to 0. You are supposed to do what's called a sign chart and check that it works. But you will find that it does when you check test points in between here. I can tell you that ahead of time because the powers of these are 1. But
Mhm.
if you were to test points, if you test 0 or maybe 6 or -5, if you test them in this right here, you'll get the positive sign, a negative sign, and a positive sign. So like it's 6, 6 plus 4 is 10, 6 minus 5 is 1, 10 times 1 is 10, which is positive. 0, you're testing on here, 0 plus 4 is 4, 0 minus 5 is -5, 4 times -5 is -20, -5 plus 4 is -1, -5 minus 5 is -10, negative times negative is a positive. Inflection points occur when you switch signs from positive to negative, negative to positive. But you don't have to remember all that if you don't want to.
Okay.
At number 16. On what open intervals is H increasing? Is the only part of, oh, this is part 1 of 6. I see. I was like, where's the rest of it? They must ask you about decreasing and other stuff. Did other problems have parts, or was this the only one? I guess
This
one of
is
them
the
had a
only
part.
one so far that's had like multiple parts.
Okay. All right. All right. One thing you might consider is graphing this.
Okay.
When you graph it, you're going to see something that looks like this. And you can get a much better graph than what I'm giving you if you want. But it should look something like that. Now, why is that important? Well, it's always increasing. Well, kind of. It's at this point right here, like if you zoom in, it kind of goes horizontal. That's kind of extreme in terms of like what it actually looks like. It does get horizontal, but it doesn't, it really, really comes up and, then it immediately goes back up the other way. So at that point, which is 6, it is neither increasing nor decreasing. And, and that means that 6 is a critical point. But in terms of like where it's increasing everywhere up to 6 and everywhere after 6.
Okay.
And you can see that from the graph. Now, if you didn't want to use the graph, you would have to take a derivative, which is fine. You can take a derivative here, no problem. 3 times r minus 6 to the power of 2. The derivative of the inside function is 1. All right, and then that becomes 3 times r minus 6 squared. You'd set that equal. You'd set that equal to 0, and you'd find that r minus 6 equals 0, or r equals 6. That's the critical point. You could make a sign chart here with the derivative at 6. And so you test points, and you're testing them in the derivative. And the derivative is right here. So you're testing them in here. 0 minus 6 is -6. -6 squared is 36. 3 times 36 is 108, which is positive. Positive means it's increasing. 10 minus 6 is 4. 4 squared is 16. 3 times 16 is 48. You get a positive number again here. So that means it's increasing. But at 6, it is neither increasing or decreasing. I always think about when someone says, I don't dislike you and I don't like you, but you're somewhere in the middle. So we did that one. I think that is everything you sent over for today.
Okay, that's fine.
Right. So we got another lesson tomorrow. Just as a reminder, I know I texted you, but I moved it to 9. Really appreciate that. I regretted putting up a 10 o'clock time, so hopefully no one else books it.
Yeah.
All right. Thank you, Alexie. I'm going to jump off now, and I'll send you notes here shortly, and I'll see you tomorrow.
Thank you.
Welcome. Bye now.
Bye.